Hello dear students, in this session we will derive an expression for self-inductance of a long solenoid. Okay, first what we'll do, we'll consider a solenoid. Okay, we'll consider a solenoid of length L. Okay, length of the solenoid, let it be L, area of cross section is A, number of turns in the solenoid, let it be N, number of turns per unit length, small letter n, and let the current flowing in the solenoid is I. So these are the initial conditions. Now flux through the solenoid is equal to BA cos theta, correct na? BA cos theta. And if you consider a solenoid, if you take area of cross section, okay, angle between magnetic field, say the current is going like this, okay, say this is the direction of magnetic field inside, angle between magnetic field and area vector will be 0 degree because this will be the direction of current. And if you take a cross section, okay, the area vector will also be parallel to the magnetic field, so that cos 0 will become equal to 1. Okay, flux is equal to B into A, but that flux is due to one turn. If there are n turns, then flux is equal to n into B into A. Flux through the solenoid, okay, is given by n into B into A. Okay, let this be my equation number 1. And 1, using concept of self-induction, okay, using the concept of self-induction or self-inductance, we also know that flux is equal to some L into I, where L is called self-inductance or coefficient of self-induction. This is equation number 2. So we have written 2 equations for magnetic flux. Let us equate it. L into I is equal to N into B into A. N into B into A. What is B? B is the magnetic field in the interior of the solenoid. Magnetic field in the interior of the solenoid is given by mu naught into N into I. Now what happened? This I and this I gets cancelled. Okay, then I got L is equal to, now what is the small letter n? Small letter n is equal to number of turns per unit length, okay, n by L. So what I'll do, mu naught into n square into A divided by L. Self-inductance of a solenoid, L is equal to mu naught into n square A divided by L. Or you can make a substitution for capital letter N also. Capital letter N is equal to n into L. So what happens? Mu naught into small letter n square into L into A. So in general, you remember like this, L is equal to mu naught into n square A by L. Self-inductance of a solenoid is directly proportional to area of cross section, directly proportional to square of the number of turns, and inversely proportional to length of the solenoid. This is a very, very simple derivation. Hope you understood this. Thank you very much.